What is the percent of the R enantiomer in a sample of carbone that has a specific rotation of 30, given that the specific rotation of the R carbone is negative 61? Hint, this question is not about the percent enantiomeric excess. Okay, pause the video now and try and get your answer. Alright, so when we're working with enantiomers, we know that the plus and minus are relative to how it is bending light. Alright, here is our equation. On the left is our observed specific rotation of the mixture. On the right is our enantiomeric excess, which is fractional, times the specific rotation of the pure enantiomer, R or S, depending on which one dominates. Now, with this question here, we have two methods of finding the answer, which is really going to be the same method, but we're going to go through both of them. So what do we know here? Well, we know that our observed is plus 30, and our R, pure carbone, is negative 60. Because our observed is positive, we know our R enantiomer is not dominant. So if we are looking for the percentage of the R enantiomer, we know that there is less of the R than S. So that automatically gets rid of B and gets rid of D. Now we're looking at A and C. Now I know if you guys are doing some critical thinking here, you know what the answer is. I believe in you. Okay, but we're gonna go ahead and solve the equation. So for this version, we actually are going to find our enantiomeric excess, which is our observed, if only I could write faster, over our pure. And we're going to take the absolute values, okay? Absolute, we're ignoring positive and negatives, and that will give us, okay, which one of you's got a calculator out? Oh yeah, percentage wise, so we like times by 100. Who has a calculator? Okay, that is 49.2%. And you might be like, great, Al, it's 49%. No, it's not. Who told you that? Not me. Hint, this is not about enantiomeric excess. Okay, great. So from here, what do? Well, we know that there is less R than S. So let's break out some equations. Percent S equals 100 plus our enantiomeric excess. So this is if S is dominating, okay? You're plussing it if S is dominating, over 2. You guys better be doing these calculations with me, and that's going to give us roughly 74.6. And for our percent R, who wants to guess the equation? Oh, you guys are so right. Wow, you guys are so good at this. That is 100 minus 49.2 divided by 2. And then obviously, is it times 100 again? I'm not sure. But it is 25.4%. And oh yes, and this one's also percent. Oh, would you look at that? It's gonna be question A, everyone. So let's discuss this a little bit further before we go on to the next method, right? For looking at this equation, you might go, why is there a plus sign? And I mentioned that before, but that is if S is dominant, which it is. So if R would dominate, then R would be plus 49. That is if R is dominating. How do I know R is not dominant? Well, because R is negative 61, R is our negative value. And our observed is positive, so less R. Okay, guys, let's move on to option 2, which is a little bit more mathematical, but it will get us the same exact answer. Maybe a little different in the last significant figure, but it's a significant figure, so who cares? Okay, let's do R is negative 61, right? Plus our observed Y, well, not observed, plus our S value. So R and S are equal, everyone. If R is negative 61, S is its twin and will rotate light to positive 61. So negative and positives here. And we know that is going to give us a value of 30, right? Correct. So let's solve this out a little bit. So R times negative 61 is negative 61R plus 60 And now, when we're looking at S here, it's going to be 1 minus R, right? Because they're twins of each other. So S is equal to 1 minus R times 61, okay? To get S, it is 1 minus R. And then 61, you move that down. Now that is still equal to 30, right? Everything's looking good here, or at least on my end. I don't see your end. Now, if we keep solving it through, negative 61R, it remains negative 61R plus, now we times it, 61 minus 61R equals to 30. I think I'm making everything a little scrunched up here a little bit too much, so zoom out a bit. Now we add these two together. That gives us negative 122 R plus 61 equals 30. And then that is negative 122 R equals negative 31. Yep, negative 31. R equals negative 31 divided by negative 122 equals, so that'll cancel out the negatives. Okay. Calculator ran away. Okay. 31 divided by 122. What do you look at that? And then, of course, you times by 100 to get the percent. That is 25.4 degrees. I mean, percent, not degrees, everyone. Percent. Oh, would you look at that? Round up. you get that 26%. So those were the two ways to solve for enantiomeric excess.